Hi everyone, welcome to lecture 27 on chance. The objectives for this video are the following. After watching, everyone should be able to, number 1, describe how degrees of belief, relative frequency and chance are related. And number 2, describe the three main metaphysical accounts of chance. So in this video we're going to round off our discussion of chapter 7. Let's start by talking about how degrees of belief, relative frequency and chance are related. And remember, these three things are all used under the umbrella term probability, and they each mean slightly different things, as we've seen. So here is a question to jog our memories about what we've seen so far. So what we've seen is how degrees of belief are what we're talking about when we reason under risk or under uncertainty, so when there is some unknown about the chances involved in a situation. We've also seen how relative frequency reports are evidence that inform us about chances. This was last time when we showed how relative frequencies inform us about our degrees of belief about chances. So what we're going to do now is dig a little deeper into these things and explicitly tie the three notions of probability together using an example. So let's suppose we're flipping a coin, like in the example from the last video, and let's simplify that example a little. So let's say we're certain that a coin is biased, but we're uncertain about which way. So let's say we're certain that there are two possibilities. Either the chance the coin comes up heads is 2/3, in which case it's biased towards heads, or the chance the coin comes up heads is 1/3, in which case it's biased towards tails. Remember, we're uncertain about which possibility obtains here. Now, last time we were interested in, for example, the question, what's the probability that the chance the coin comes up heads is 2/3? And we saw how relative frequency informs us about our degree of belief in, for example, the statement, the chance the coin comes up heads is 2/3. All that was different last time were the numbers involved here. Now this time we're interested in this question. What should our degree of belief be that the coin comes up heads? And when we unpack this question, we'll be able to put everything we've done together and see how these three things of interest, degree of belief, relative frequency, and chance, are related. So let's focus on the question, what should our degree of belief be that the coin comes up heads? Or what's the probability that the coin comes up heads? Well, the probability that the coin comes up heads is equal to the probability that the chance the coin comes up heads is 2/3, times the probability that the coin comes up heads, given that the chance the coin comes up heads is 2/3, plus the probability that the chance the coin comes up heads is 1/3, times the probability that the coin comes up heads, given that the chance the coin comes up heads is 1/3. Now this is a bit of a mouthful, but you've actually proved this. This was assignment 7, question 2. So let's look at what we've got here. On the left is our degree of belief that the coin comes up heads. This term is our degree of belief that the chance the coin comes up heads is 2/3. This term is our degree of belief that the coin comes up heads, given that the chance the coin comes up heads is 2/3. This term is our degree of belief that the chance the coin comes up heads is 1/3. And this term is our degree of belief that the coin comes up heads, given that the chance the coin comes up heads is 1/3. So what we've got are a bunch of degrees of belief on the table. Some are degrees of belief about chances. The final thing we need to see how everything fits together here is a principle connecting degrees of belief and chances. And the principle is this on the slides. Our degree of belief in an outcome O, given that the chance of O is P, is itself P. This we make under the assumption that our evidence for an outcome comes only from the knowledge of the chances involved, and we call this principle principle star. Now using principle star, we can finally see how degrees of belief, relative frequencies and chances are related. Look back at our expression for our degree of belief that the coin comes up heads. Then we can apply principle star to this term and to this term. And principle star tells us that our degree of belief that the coin comes up heads, given that the chance of the coin coming up heads is 2/3, is itself 2/3. And principal star also tells us that our degree of belief that the coin comes up heads, given that the chance of the coin coming up heads is 1/3, is itself 1/3. So our degree of belief that the coin comes up heads is equal to our degree of belief that the chance the coin comes up heads is 2/3 times 2/3, plus our degree of belief that the chance the coin comes up heads is 1/3 times 1/3. And now we have everything on the table. This expression we've just written tells us that the proper degree of belief that the next coin flip is heads is an average of the possible chances, with the weights of the average being the degrees of belief in the proper chance hypotheses. We've met these weighted averages before, they are expectations. So what this expression tells us is that degree of belief is the expectation of chance. That's on the slide there. This is itself a principle because it follows from principal star. So in this new expression, we have these terms, which are degrees of beliefs, and now we've got these terms, which are chances. And we've used principal star to get these chances in this expression. So now we no longer just have degrees of belief appearing in the expression, we've got degrees of belief and chances. And then the last thing to say is about how relative frequencies fit into this picture. And that we've already seen in the relative frequency video. We said there that relative frequencies inform us about our degrees of belief about chances. So relative frequencies fit in like this. They inform us about these things, because they are degrees of belief about chance hypotheses. Now, if we carried out some coin flipping experiments, for example, we could use the relative frequencies to give everything numerical values here, and then we would recover our degree of belief that the next coin flip is heads using the expression, which is just what we were doing in lectures 25 part 1 and part 2. So this is how these three things relate. Things I expect you to be able to do is tell me, given an example like this one, what the degrees of beliefs are, what the chances are, why the chances have replaced the degrees of belief in this last expression, and the reason is principal star, and what relative frequencies inform us about here. So, we've seen how they all relate, and the question that's left is what is a chance in and of itself? So we'll round off our discussion by looking at three metaphysical views about what chances are. Here's the first view. View 1 says chance is primitive and irreducible. People who think of chance in this way think of it like a force in physics. Now what's good about this view is that it avoids the shortcomings of the other two views, which we'll see later. What's bad about this view is that it has little to say beyond what we've sketched in this video and in the last three. For example, physical theories about chance allow you to predict things about chances, but all we can observe empirically is relative frequencies, so think of your coin flips. And so, as per the slogan of the last video, our rational degrees of belief about chances are influenced by observed relative frequencies. And conversely, what we believe about chances influence what we think we should be seeing in our relative frequencies. And this is pretty much all we get to say on this view of chance, so not really anything beyond what we've already said. The second view is that chance is reducible to relative frequency. We call people who hold this view frequentists, and they tend to think of chance as relative frequency in the long run, precisely as the limiting relative frequency in an infinite sequence of trials, so an infinite sequence of coin flips. Now, a good thing about this view is that we now know, in a way, what chances are. They are just limits of relative frequencies. But there are some bad things about this view as well. The first is that infinite sequences of trials might not exist. We can't sit and watch an infinite sequence of coin flips. And another problem is to do with the infinite sequences themselves. We have to know which are the right ones. For example, we might imagine a coin flipped 1 trillion times might exhibit some kind of wear and tear and bias the coin at that point in the sequence. One way around this is to talk in terms of hypothetical relative frequencies. So imagine we flip a coin that doesn't wear infinitely many times. These views, however, are circular because you would want more precisely to say something like, imagine we flip a coin infinitely many times such that the factors determining the chances that the coin comes up heads don't change. But once you've said that, you've appealed to chances again, and that was the very thing that we're trying to explain using this example. So that's circular. So we'll leave the frequentist view to one side then, and we'll turn to the third view about chance. The third view says that chance is reducible in some way to degree of belief, and we call people who hold this view personalists. Now, a good thing about this view is that, like the frequentist view, we've made this concept of chance less vague. It's now just a degree of belief. And what else can we say about it? Well, if chances are degrees of belief, then they are personal. Different rational agents, like me and you, might assign different chances to the possible circumstances. And this is something we want to avoid. You don't want everyone having their own chance of something happening. But it turns out, in certain circumstances, that we can avoid this problem. So let's say I determine my chances that a certain coin comes up heads. Let's call that a T chance. And let's say Alex determines her chances that the same coin comes up heads. We call that an A chance. Then, if myself and Alex construct our chances using the relative frequency of the coin coming up heads in such a way that they give independent trials, then my T chance and Alex's A chance actually do agree in the limit. So if we flip that coin infinitely many times, our personal chances are the same. So this gets some way around the problem of everyone having their own personal chance of something happening. And this result, the agreement, is due to a guy called De Finetti. So there are some plaudits for this third view. However, as soon as we start talking about infinite coin flips again, this view inherits the problems that we talked about when we discussed frequentism, that arise when we consider these infinite sequences. So we'll leave that discussion here, and we'll summarize by saying that the metaphysical nature of chance is a difficult one to pin down. So, next, we're moving into the final week of the course. We've talked at length about scientific inductive logic, and then at length about probability. And so in the final week, we'll link those two big topics together by revisiting some ideas that arose when we talked about scientific inductive logic, and seeing what light our discussion on probability can throw on those issues. We'll start in the next video by talking about hypotheses and deduction. So have a go at your self-reflection questions, and I'll see you next time.